Data science has been becoming a growing profession and is also the heart of many organizations. That's why Data Science Portugal was born. The first community created by data scientists for data scientists. DSPT wants to gather anyone who works in the field and chat about any topic over this great subject. All members from our team are committed to make sure that the data science field evolves in a healthier and stronger way. To ensure that the focus is on sharing knowledge, we guarantee that our stage is not a place that supports any commercial or recruitment content, and our kind speakers are committed to share their experience for free. We want you. Let's do bigger things together. Join us at any event all around Portugal or online.
Hi everyone, welcome to today's DSPT webinar. My name is Isabel and I'm going to be your host. And this will be our agenda. I will first give you a little bit of overview regarding DSPT. Then we're going to have our talk by Catarina Silva, The Rise of MLOps. Then we're going to be followed by a short Q&A session. And news for today, we're going to have a networking way of doing it. It's going to be beta, but please stay with us until the end so you can really enjoy from it. Regarding the SPT, we are an informal community of data science enthusiasts, and our main proposed purpose is sharing knowledge and experience. We've been doing this since 2016, and we already have some background. And in order to do this, we have kind of a do's and don'ts philosophy in order to promote and have the best events ever. So have that in mind once you have your proposal checked with us. If you have an idea or if you have something that you want to share with our community, please use our call for proposals to do that. So where can you find us? We are in Aveiro, Braga, Coimbra, Lisboa, and Porto, and also online. So have a look in our website, datascienceportugal.com. But don't forget to also check our community on Slack, Facebook, Meetup, and LinkedIn. Join us, please, so you can have the latest news from us. I want to give a big shout out and thank you for our sponsors for today, DevScope. Without you guys, most of this wouldn't be possible. And for the Q&A, please don't forget to post your questions on YouTube chat. We'll make sure that everything gets answered. So regarding our speaker, today we're going to have Catarina Silva with us. She is a senior research engineer at Unbabel. She is the mother of GPUs, the freer of CPUs, and rightful queen of NMT. She also tells you that she is a Star Wars fan, an engineer, a developer, and in that exact same order. Hi, Catarina.
Hello, good evening, everyone. So I'm Catarina, and I work at Unbabel, and I'm here to talk to you about the rise of MLOps. And thanks, Isabel, for the colorful introduction. So let's get this started. Oops. Okay. Yeah, so what I'm going to talk to you about today is I'm going to try to talk a little bit about machine learning in the real world. What are some machine learning operation problems that exist and that kind of lead to the necessity of this MLOps new category? What are some MLOps tools that are out there, and a little bit about the maturity of MLOps and some maturity frameworks. And my goal really is to give you a little bit of an overview of the why, the what, and the how of MLOps today. So it's going to be like a shallow overview of this topic. So we're kind of in the last few years coming into this era of machine learning. So data science is not new, obviously. There's been data analysis and data science for a long time now. But there has been a recent improvement in a lot of different and a lot of difficult machine learning fields. And so this has created a lot of hype around this, but also a lot of companies have been trying to kind of get into machine learning and data science. And so it kind of brought a new light over this topic. So these recent improvements are really a big motivation for companies to do machine learning now. Also, the new techniques that we have that improve our resource usage, and even in a way, the fact that these resources are more and more available to us, even though like they're still expensive, obviously, it's not that easy. But comparing with, I would say like 20 years ago or something, it's definitely much more democratized in a way. And so there is more access to resources, and there are also new techniques that improve the resource usage for these particular applications. There's also a huge economical motivation, because with these recent improvements and this resource usage, obviously, it's cheaper and there's more impact in doing machine learning applications. And there are several new areas that are being explored. So there is a huge economical motivation behind it. And as I mentioned, there's also a lot of hype. So there's also people doing AI for the sake of AI, and maybe it's not needed in 100% of the cases, but it's definitely an interesting field, and it's definitely something that a lot of companies are now going into. So you have tons and tons of different applications, from recommending systems, which are like very much used in retail and in any like application, for example, music or videos or something that wants to provide you with like recommendations on content. From that to translation to image recognition, which are much stronger or much more difficult applications of AI. So all of these things are kind of leading companies to invest more in both data science and, in some particular cases, in AI. And this is actually a study that I found from Algorithmia that I found very interesting. And it's trying to analyze, like, over the different companies that work or that touch a little bit AI and data science, like what is the status of that? And this chart is particularly interesting for me, because if you really read what the chart is saying, the first three columns, basically half or more than half, actually about 55% of the companies that were questioned here, they don't even have any model in production. So they're either evaluating use cases or starting to develop models, or at most getting some developed models into production. So they don't even have models in production right now. So they're not maintaining them, they're not deploying them. But even so, there's a number of new positions coming up in these companies, like machine learning engineer, machine learning developer, architect, data engineer, machine learning operations, which is closer to this MLOps thing. You're going to hear about AI ops, sometimes data ops. There's a lot of new job titles, and it really depends, like, from company to company, what these job titles mean. But it's really interesting that even so, like, more than half of these companies are not really supporting models in production at the moment, but there's all of these new investments in these positions. And you're also going to see this, so this is not a quote, you're going to see this like around, I don't know, different news pieces, blog posts and whatnot. This percentage might change a little bit, but a big part of machine learning projects never make it into production. It might not be 90%, it might be 80-something%. But this is an interesting fact, right? So that so many projects or so many new models or equivalent, they don't really make it into production. So what is happening there? Obviously, if there's an economical motivation, then you would like things to get to the products. And there are several blockers for the success of a machine learning project. Either it's a small project or a big project. But the first one is that data can come with a lot of issues. And this might be because it's scattered across different places. So just to get all of the data, you need to combine multiple sources. It might be because you don't even have access to the data. So you set up your data science team, and then suddenly they can't even, like, they don't have the permission to obtain the data that they need for a particular project. And so you have this access issue also. When you're trying to combine different data sources, you also need to obviously make sure that the formats all match. You need to make sure that the data has that the integrity of the data is there. So there's a lot of, like, specific issues to the data that don't come up in other software engineer applications and come up mostly in machine learning applications. And then obviously when you go from the data to models also have a completely different set of requirements. And this can be because they need, like, much more resources, whether this is CPU or memory, or if you really need, for example, a GPU for your model, which is the case in a lot of deep learning applications. But also when you're deploying a model to production and when you're maintaining a model in production, this is it. So you still have the same requirements as code, but in a different. But you have a whole new set of different requirements when you want to monitor this model. So there's a bunch of new things around the performance of a model that are completely new, and so this can also be a blocker, especially for machine learning projects, for recent teams or companies that just started to invest in that. There's also a gap between research processes and production processes usually. And if you think about like stronger AI applications, let's say image recognition or anything around image or language or something like that, you have highly specialized people usually that are hired to do the AI part. And it's very tailored for research in a lot of cases. And so when you have that, and when you're in that research stage, you have certain metrics that you're optimizing, you have a certain scope, but there is still a gap between these research processes and how do you connect that to the production processes? Because as soon as you want to put something in production, you have a lot of new success metrics that you might need to use, and suddenly your scope is not as contained. And so this really needs to be a smooth process. There needs to be a smooth transition, which needs to be well thought. And because this is usually not the case, what happens is in a lot of situations, AI is like a one-hit wonder. So you deploy once and it's working, it's in production, and then there's no follow-up, there's no process to actually monitor and have quick feedback and like rework the model and whatnot. And people are a little bit like, okay, this is working, it's in production, nobody touch it. And we don't want that, obviously, but this can be a blocker for the full project in a long-term way to be a success. And this usually is also a little bit touchy. So what I was saying about, okay, it's in production, it's working, changing it is a big pain, so let's not do anything. It's also related to the fact that it's a high interest debt accumulator. And what I mean by this is that, so there's a lot of like little things that if they change, they can impact the performance of the model. It's really, really sensitive, right? So you have the data distribution, you have your parameters, you have the way you process the data, which if for some reason is slightly different than what you did in your research stage, can completely backfire. So this is really, really a high interest debt accumulator. And this can be a problem also if you don't know how to handle with those things. And lastly, but not least, is there are a lot of silos between the teams, and whether it's the data scientist team and the engineering team, or if you have very restrict policies about the data, for example, there can be a silo there. And it can be really hard to make sure that these things run smoothly. And people are very attached to their ways of working also. So even if you have the will to do some changes and to have a little bit more of this kind of MLOps process, which would be similar to how DevOps work, it can be a bit hard to convince people that like, we need to change these things, because people can be very attached to what they were doing before. And in reality, like the machine learning code is not isolated, right? So it lives in this ecosystem that depends on a bunch of other things, from the data collection to its verification, the testing and debugging of everything, the models, the codes, the pipelines, the resource management, how do you manage your data sets and your models, and how do you serve them, like the serving infrastructure, the monitoring part. And this usually is like a big ecosystem that needs to be linked in like a very smooth way for everything to work properly, and it's usually not. And we have this ML code that we now want to put in production, and in a lot of cases things are a bit messy and they're not like they don't have the right connections in between these things, and obviously this is a problem. So this can be a huge blocker for machine learning success. And another part of that report that I mentioned before that I found like also super interesting is that this really reflects in the way people work. And this chart in particular is pointing out the amount of time that data scientists spend deploying models, and it's organized by company size. But it's super interesting that in almost all of the company sizes, I think except for the 5,000 to 10,000, more than 50% of the cases also, data scientists spend more than a quarter of their time just working on the deploy of a model. And this is a huge amount of time, right? Even if it was just a quarter of your time, if you code, and if you think that to deploy your code, you would need to spend a quarter of your week just doing like working on the deploy part and not really on the actually development part, this would be really weird, right? And in the same way that DevOps kind of brought a change to the way we package and deploy code and put it out there, the question is, can MLOps bring the same change to machine learning applications and machine learning code? So just to give you tiny overview from where I'm coming from and why I'm talking about MLOps and all of that. So I work at Unbabel, and we're a company where AI is really like one of the central pieces of our product. And we also have a high cardinality of models. And what I mean by this is that there are several applications, several different projects of machine learning, and there are several models in each particular project, because we work a lot with the client adaptation of these models. And so we have really a huge amount of models that need to be managed, need to be constantly deployed, need to be updated. And we've started so small, right? So as every startup, we started like with some sort of MVPs and whatnot, but AI was always one of these central pieces. So you really saw, like, as we scaled, we really saw these growing pains, and we really understood the need for solving these issues. And there is just a small example of our pipeline, and you can see we have machine translation as really one of the central pieces of our product. And then quality estimation is another machine learning application very much associated with language. And there are others around this that are also important and that complement our product. But this is really the fact that we have AI in our pipeline is what allows us to be cost effective with the translations. And so it's really, we can't detach the product from this piece. And so in this particular case, I'm kind of in a setting where I see like completely 100% the need for MLOps. And on the other hand, I also teach in the Lisbon Data Science Academy, and it's really interesting. And when I was thinking about this presentation, I was kind of assessing the two sides. And it's interesting because we teach model deployment to the students, but in a very, very like shallow way, in a very nothing MLOps at a much lower scale. And because mostly we teach a completely different type of applications. It's mostly like small data science projects. You can imagine, for example, trying to help the sales team predicting what will be the volume of their sales in a certain month or something like that. And those would be kind of applications that you have more on the side of the product, right? So they're not necessarily central to the product or anything. And also because usually when you're teaching students, they're still at a lower level in a way in terms of learning. And so you don't want to just bombard them with all of the concepts. So this is kind of interesting for me because you can think of the need for MLOps at different stages of your product and for different types of applications. And I would interpret them differently. But so what is MLOps? What is like this big topic that I'm talking about? So MLOps is just a set of machine learning and engineering culture and practices that have as a goal to unify the development and operation of machine learning systems. And this is very similar to DevOps, and in a way it just tries to basically shorten the development life cycle of developing ML and putting it in production, and in this way to increase the organization's ability to deliver high quality machine learning projects, right? But if this is basically just DevOps for machine learning projects, so what is the big difference? And I would say that machine learning MLOps in a way will differ from DevOps in the same way that machine learning projects differ from traditional software engineering projects. And so how do they differ? In traditional programming projects, you basically have some data coming in and you design your program, right? And it produces some output, but you're the one defining your program. So the desired behavior is very, very well defined, and the program that you were writing is very well known. Well, we can obviously argue about if product requirements are good or not, or all of that. But when you decide to implement a certain feature, you know exactly what you want to implement. And in machine learning applications, it's a little bit different. So you have the data, you know what your output, you know what the output you want is. Let's say, for example, for image recognition. So you have your images and you have some labels, and this is supervised machine learning, obviously. But you don't know all of the rules. You don't know how to define this program. So what you do is you train a model, and so the output of this training of this algorithm is the actual program. And so in this particular case, the desired behavior is obviously not 100% defined. If it were, we would maybe write rules or something, except those rules could be very, very large. And the program is actually the result of this algorithm, like I was saying. And this can lead to a lot of unknowns about how the program is going to behave with different data or with in a different setting. And so this can clearly be an issue there. And so in this way, you could see in a very, very simplified way, software engineering like a traditional application. So if you're developing it, you're coding, you're testing it, deploying it, and then having this cycle of monitoring and improving. And what DevOps brought to this was kind of these notions of continuous development, testing, and integration. And you create kind of tools or pipelines that are able to run these things automatically so that you really, really focus on the development. You really focus on writing new code and putting it in this cycle, and are very fast to deploy. And the faster you are, the better, because you have faster feedback. And in the same way, besides the development, testing, and this integration part, you also have continuously deploying. And in one of the principles is usually that you should deploy as often as possible. Also continuous monitoring, and there's a big emphasis on this. And you can define the infrastructure that you need as code. And so these are kind of the traditional things that apply to this loop. And when you have a machine learning engineering application, so these things still apply, right? Because you're still writing code, whether it's the training code or the inference code. So you write some training code, you test it, and you deploy it somewhere, or you're testing it somewhere. And usually you're running experiments. So if you're trying sort of like new, different like variations of the algorithm, you're maybe like doing some experiments with the well-known data sets, you're training models, you're comparing these results and going back and forth with this loop. This loop can be like really long. So this is not something that maybe happens in one day. For most cases, it can take weeks or even more. And after you have this, and sort of, let's say that you converged into something that you really want to keep and implement, then you actually deploy it to somewhere more stable. And you have this also monitoring and improvement, because there's still things that can go wrong with your code. And you're going to run some like really ML training in the final data sets to produce the model that's actually going into the product, right? You can still compare the results if you had some previous model, but usually that's more or less the output that you have, right? And so after you have this kind of, let's say, production training cycle, you package your model, and you still want to test it and validate other aspects of it and deploy it into the production setting. And then in the production setting, you have the same loop, like I was saying, for the inference code. And so as you see, this is a little bit bigger, and it has more aspects of things that you need to take into account, and the scope is a little bit broader. And I'm going to emphasize that the other principles, like the DevOps principles, still apply to all of the coding part, whether it's in the training part or the inference code. But now let's talk a little bit about the parts that differ. And in essence, machine learning is still experimental, and models are often black boxes. So like I was saying, you don't know exactly how your program is going to behave in every single scenario. And this is very hard to predict, obviously. And even differentiating between two models is not super easy. So you can't really just, let's say in a deep learning application, you have two final models, and you're not going to like do a diff between these huge amounts of like numbers, because that's what a deep learning model is. It's just like a bunch of numbers that have a certain behavior, and you can't really differentiate between them. So the way you have to do this is by setting some metrics, and these metrics can be the same. Well, they usually are the same as the experimental ones, but there can be several. So it's not limited to one. And then, so the part of the metrics is also a little bit related to how well you know what is your application, to how well you can define those rules. And so this is a very hard problem, and you really need to be able to track everything about your model. So all of these metrics, even if you have like 20 different metrics, you need to track them all and have some sort of way of deciding among them what is your best model. And then once your like environment evolves and you have new data and new things coming up, this can have an impact on performance. So you also need a way of tracking this and making sure that you can detect when there are issues. And this is like a very hard problem in machine learning right now. How do you version models and make sure you can easily switch between them with some sort of proper reasoning behind it? They're also very hard to scale. And usually, like I said, even the previous slide, if a model works great in a small environment, it doesn't necessarily mean it will work great in any case. and it's actually the opposite. You probably won't if you change the scenario too much. Besides the models themselves, usually the data sets attached to these models are very big, and you also need to track them, right? Because you need to know what generated your model. And so this is also an important problem, and version control for models and data sets is not as simple as version control is for code. But there are things out there already to try to provide that. And like I said, models can also be big, and especially in language, for example, we're seeing them getting bigger every day. Like there's these huge generic models trained on millions and millions of examples that are being provided by big companies. And there's even a lot of conversation around the environmental impact of all of this. So they're really getting bigger every day, and this will have the same issues as data sets. And the inference can have its own problems. So for example, one can be the latency of this inference. So if you have a huge model, the time that it will take to predict something can also be very big. And you need to account for all these trade-offs when you're trying to scale, obviously, and like how many resources you need for a particular model, how much time it's taking to respond, how many requests you need to satisfy with that said model. So this is obviously hard to scale. And sometimes they can be hard to reproduce. And this image I've posted here, it's mostly linked to the research side. So sometimes you see this paper promising amazing results, and you try to replicate it, and it yields nothing. And this is fine in some up to some extent, right? When you're talking about papers, but this cannot happen inside the company, right? So if you have somebody running an experiment, and the experiment is amazing in some very contained experimental set, and then as soon as you want to put it into production, every other validation just breaks, it doesn't work for anything. This is really bad. So you really need to make sure that you have the proper data sets, the proper connection between these metrics that you use for research and these metrics that you use for success. What does it mean to when you deploy this model in production? What will success look like? And so we really need to take this into account. And once again, to track all of these results, to know if you want to see, for example, if why did something that worked so well in a particular scenario suddenly completely backfires, you need to have access to the scope. So you need to be able to go and debug and see, okay, what was the data that was used for this? What were the metrics that were initially published? What are all of these things? And so really reproducibility is the key here. And it will lead to a more efficient process in terms of machine learning. And this is not only from the point of view of experiment tracking, but also of managing these artifacts, so models and data sets, and also having a good way of knowing the data provenance. So every single step of the way, what was the data set that was used for your model? Where did that data come from? What was the processing that was done on top of that data? What were all the validations done? All of these things are super important. And there are some tools out there that already provide at least part of this. One of them is MLflow. There are others, which in this particular case, for example, it gives you a tracking server, so you can register all the parameters, metrics, artifacts, everything kind of in the context of a particular machine learning training that you did, but also a sort of model registry, which is important more from the model management point of view. So when you want to deploy models and make sure that you can track everything that's in staging, production, whatever environment, or that you archived or something like that, and it provides these things. It's not the only tool out there, it's just an example. So the second thing is models are only as good as the data they see. I already mentioned some aspects of this. But really, if models are so attached to the data, then the process that you have to obtain this data is really, really important. And it can come from many different sources, as I mentioned before. And this can lead to blockers if you have problems with access in between teams or in between different products or something like that. So a solid data platform here can be really a real game changer for data science teams. So we don't want to have too much access, in the sense that you shouldn't have access to things that you don't need, but you should have access to all the things that you need to do your job. So to do the machine learning model that you need to do, or the data science model. I'm using both interchangeably. But this is really important. So having a strong data platform with strong data extraction pipelines, with the validations over the data integrity, is really an important factor in this particular scenario. And jumping now to the part of how data impacts models, well, real-world data is constantly changing. This is this shouldn't be news to anyone. And there are different types of data shifts that can happen. So if you have here in this image, and I've put the link to the paper there, you have basically two different distributions, right, represented by different colors and shapes. And you can have a sudden shift from one to the other. You can have a more gradual shift, an incremental one, where you have those like weird blobs in the middle, where maybe it was not a breaking point, but that it just like slowly changed from one to the other. Or you can have recurrent things or blips. So recurrent, you could imagine recurrent being like if you're working in retail, there are particular times of the year where things might shift to another distribution because you have particular holidays or because like something else is happening, or you have sales or something. And model degradation is a real thing that can be caused by by all of these shifts. So you need to be able to, well, not only detect it, but actually handle it. And one really important thing, and if you focus on the three first data shifts that I'm looking at here, so sudden, gradual, and incremental, there's sort of like some point in the middle that you can identify that would be a good moment to shift from one thing to the other. And this is obviously not the only solution, but this is a very helpful thing. So continuously training your model will already help, right? So if you're constantly retraining with new data, you're much more fast in reacting to whatever distribution changes may happen. Obviously, you still want to have alerting and monitor and be able to actually know that the distribution changed. But this is one important technique for that. And this makes, and continuous training makes sure that your model is always up to date, and you have you're using the most recent data available, which also in theory should increase the impact that you can have. So if you have just a regular experimental pipeline, as I'm showing here, so this scheme is from a Google post from that is linked below. This is just an example of any experimental pipeline, and you can run this manually. For example, you could pull it, run it manually, it works, you generate a model, and that model goes to the prediction service. So obviously, if you want to have continuous training with something like this that you need to run manually, it's not very efficient, right? I don't want to pull this, run it every week, verify every week, like myself, if things are okay. It's not good. So you want to have automation over this, and you want to have this notion of a continuous training properly implemented. And the top part of this drawing is basically that same pipeline, but then instead of just like producing the model and putting it into the prediction service, you package this pipeline and you launch it into some environment where you can trigger this pipeline due to different stimulus, like, okay, there was some alert and I need to retrain this, or I have some signal from production coming and probably I should re-trigger that. Or it can just be scheduled. You can just run it like every day, every week, every month, or something like that. And so as soon as you put it in this environment and you can control it and define what triggers this pipeline, then you can have this continuous training always happening. You're sure that the code running here is the most up-to-date. Oops, sorry, I need to shut this down. You are sure that the most up-to-date code is there, and you can have the benefits of this continuous training. And so the training infrastructure here is also like an important point. So most machine learning applications need like these different requirements, and I've mentioned before, even for inference, but particularly in training, usually you need GPUs, for example, and this is costly. So you don't want necessarily to always have them up. So you might have peaks of usage because you have several people working on different models. And typically they're shared among several researchers. And so you rely on some sort of queuing system to handle this. So these are some aspects of training infrastructure. And putting all of this together, these are kind of principles a bit more focused in this notion of continuous training. So this data accessibility and kind of platform thinking when handling data, the part of continuous training and the pipelines themselves, the continuous monitoring also from a machine learning point of view to kind of tackle model degradation, being able to detect the distributions and their shifts and all of that, and the training infrastructure management itself, which usually is attached to kind of a more cost management goal. And finally, so this is the last thing about machine learning operations, is that it really takes a village to deliver successful machine learning projects. So it's not only the machine learning engineer that does the whole thing, and it has an amazing impact in the product. So you really have all of these different pieces that need to fit together and that need to produce a smooth transition from one to the other. And so you may have the data engineers working on the data pipelines and the labeled data. You may have the data scientists or ML scientists or ML researchers doing the training codes, the models, and kind of putting the models out there, deploying these models, and the engineers working more focused on the deployment part and the production part. And this image for me is interesting because in the original article where it's inserted, this image is representing the silos. So this is an attempt at representing the silos. But if you think that there's good contracts between one and the other one, so if you imagine this labeled data, for example, this boundary between one and the other, if it has a proper contract, then this can work very well, because things can just be released, hand over, you can have the proper tooling for the data scientist to really go from the training until deploying the model into production. And this is like a state where you really want to be at, that the person can, as the developer, kind of produces the code and can lead all of the single stages, obviously supported by the proper tools, until it deploys the code into production. The same can happen with the data scientist handling the model. And so just putting all together, you have like the old principles from DevOps that still apply very much to all the parts of the code, and you have this kind of new principles, like roughly put, that really are important for these machine learning scenarios. So how can you start using MLOps or doing MLOps or just looking into MLOps in general? So first of all, it can bring high value, but it's not a one-size-fits-all. So different applications will need different aspects of everything. And there are different maturity levels. So this is not a one or zero thing. You don't have MLOps or not have MLOps. And there's a trade-off between the value that this brings and the investment that it needs, obviously. So, but the thing is, if you have an AI application or a model without MLOps, like I said before, you put it in production, it seems to work, and then you don't really know anything more about that, right? But if you have that with MLOps, then you have all of these things around it, like retraining, you track accuracy, you have proper versioning, you know what you're serving, you know how to inject the data and be quick to respond. You can have security aspects on top of that. You know how to, it's easier to scale. And you can monitor pipeline and your use of resources. And all of these things bring much more information about the success of this machine learning project or model that you're deploying. And this is really important. So one thing that you can do is just think of different aspects of this like machine learning project or application that you're building. Like, do you have one model, or do you already have lots of models, or you're going to have at some point lots of models? Or how complex is the process to train your model? Is it a really simple thing where almost you have the data coming in like really a neat format that just is passed on to some simple model and then it's done? And that can be a very simple training process. Or you can have a lot of processes that need to get done, like a lot of pre-processing to the data, a lot of transformations, like merging different data sources. And you can think of these aspects as things that might give you some insights, like how much you need MLOps, right? And obviously, if you have tons of models and a huge training complexity, you're going to have a high benefit of having these things like very well defined and very smooth, and a lot of tools to help you with these processes. On the other hand, if you have like a very light train process and maybe you're supporting one model and maybe it's a side application, it's not even like impacting your product that much, maybe there's not that much benefit. You can maybe think about it when you're starting to scale. It also depends if you're just producing an MVP or not. But this is something that you can just like keep in mind for more of a scaling stage. And then like you have other parts which you have like sort of a mid benefit here, right? And like if you have a lot of models but your training process is very small, is very light, then maybe you want to focus on the model lifecycle, on managing these models in production. But if you have, on the other hand, just one model but a very like complex and painful training process, then maybe you want to like work on the whole pipeline continuous training thing and really make sure that that things there are working fine. And so there are other aspects. Obviously, these are not the only ones. These are just some examples. But it's really important for you to like assess like the trade-offs between those. And so just to give you like a really like high-level overview of all of the different parts, this is actually from another blog post, but I found this blueprint very interesting, and it talks about the different aspects. So you have the experiment tracking part. You have more of the model registry part there. You have the inference also of the models that is a little bit separate. And you have like all of the data flow automation. And there's a lot of interesting tools here. So this is really just a high-level picture to kind of give you a starting point to look into some of these tools, especially if you already know, for example, okay, this model registry thing is really interesting. And yeah, I think this might really bring value into my project. Then like there are some tools here that might be of interest to you. One of them, like the MLflow thing that I mentioned. But if you're still on another part of the project, or if you're not really working too much with this heterogeneity of models, but you have like very complex data processes, maybe the data transformation part is really where you want to focus. And just to give you an example of like what pipeline management looks like, this is just some screenshots from Airflow. Which is a tool that I actually have worked with, and this is why I'm showing it, because I feel a little bit more comfortable with it. So you can have all of your pipelines kind of centralized and scheduled or triggered by different signals from production, or just manually go and trigger some pipelines very easily. They're usually defined as direct acyclic graph, so DAGs, and they can be simple like this one. This would actually be a simple pipeline, or they can be very complex and huge and be a little bit scary. But one thing that I do want to say is, like, it's not because you put a tool there that you suddenly have your problem solved, right? You can still write your training pipeline in a poor way, and this can really backfire. So you really need to make sure that you also have a good process to actually put these pipelines into place, so that you have also a lot of testing, a lot of those other practices about DevOps, right? A lot of really strong test suites for different aspects of what these pipelines should produce, so that you don't put a pipeline in production and then it's constantly breaking and you need to just like constantly go back and patch it. So this is really important. The tool itself is not going to solve any problem if the pipelines are poorly written. So this is a very important aspect. Tools don't solve things by themselves. And these are just other examples of pipeline management tools. So you have Airflow, you have Kubeflow, Prefect, DVC, Dexter, Luigi, and they're all like, they all have like slightly different directions in a way. So DVC, for example, I think is a little bit more focused on the data ingestion part, while Airflow is like a lot more about this pipeline management and has this beautiful interface. Well, beautiful for some people, and but they're all kind of focused in this part, the pipeline management, which is an important part of this process. And so, just a final note on the tools is that even though there are a lot of tools out there and it's changing a lot, so every couple of months or something, there's a new blog post about how all of the other tools are terrible and somebody just developed the tool that is going to save everyone. The maturity level of these tools is really quite low. So they're all very recent. They're all still under development. There's still a lot of unknowns about what are the features that are really, really important for these projects and what are not. And once again, this can depend on the scenario. So there's a big tendency for some of these tools also to try to solve everything. So they're trying to solve pipeline management, model management, dataset management, versioning, the monitoring part, and this can get very chaotic. So there's really a lot of space still for these tools to grow and to become real players in this topic. And so this is more of a disclaimer. So you might be very hopeful when you start using one of these tools and then find out there are some like important features, at least for you, that are missing. But this is normal because it's a very recent field, and only now these tools started to come up. And this is just one of the potential maturity frameworks. So Google has one, Microsoft has one, all of the big companies have one. I think this one, I kind of inspired it. I took inspiration from the Microsoft one. And this is just like defining some levels where you can be at in terms of machine learning operations, right? So the initial one is obviously you don't have any sort of MLOps. Like your teams are all disparate, releases are painful, everything is manual, builds, deployment, testing, training, everything. And like then you can evolve to some sort of like having maybe DevOps in place, but not really MLOps. So you have a little bit of a less painful release process, but still there's a lot of manual things, and only the code part is sort of solved. And then you start really going into the automated training part, where maybe your training environment is now fully managed and it's traceable, and you have a little bit more ease in reproducing models and in automating things. But you can still have some problems in terms of like knowing all of, like in terms of the tracking, like the data provenance, all the parameters, how to relate all of that, and how to manage the production side of the models. And then like as you go further into level 4, and where you want to have like everything fully automated, and you have this management all tackled, and you have the metrics centralized, and you can access everything that you need, like then you really start to see the benefit of MLOps, and your processes should become much more efficient when you're at this stage. But above all, and like I mentioned before in the disclaimer, the tools by themselves don't solve anything. And the automation is really important, but it's not the main point. So as DevOps is about cultural norms more than anything else, which goes far beyond automation. And this quote I took is from the DevOps Handbook, which is a really interesting book. For MLOps, this is the same thing. So you really need to focus on the collaboration and what are the needs of the data scientists, and what are all the teams that are involved in this process, and how can you improve this collaboration so that there are no like barriers in between the different stages. And so I really want to stress that out, that it's about this culture and this collaboration between teams. So just to finalize, what will success look like if you have like proper MLOps in place? Well, first, you should see it in the time to value of new models and projects. So it should be much simpler to actually see the impact that a new application that you have or a new model that you just developed is having in production. You should see it in costs of training infrastructure, because if you have all of these things monitored and kind of in mind, then you can optimize them, and you can really see like the trade-offs between these costs and the impact that you're bringing and the benefits that you're bringing. And finally, it's really about the efficiency also of data scientists and machine learning engineers. So going back to the beginning, if you have data scientists like spending 1/4 or half their time just deploying models, then they're not really focusing on their job, which is like improving those models and bringing even more benefit into your product. And that's basically it. So let's maybe jump to the questions.
Hi, Catarina. Thank you. Thank you really much for your talk. We have a big set of questions actually for you.
Okay.
So let's start with this one. Don't you think that in general companies are still a little bit skeptical about having MLOps positions?
Yeah, definitely. So, I mean, MLOps is just a kind of a new buzzword, right? Because in essence, you don't need to have an MLOps person specifically to actually be doing these things. So you can still be focusing on automating these things and just bring these tools or these new processes into your team, into your data science team, without having a specific MLOps person. In the same way that you could bring practices of DevOps without specifically hiring a DevOps person. That started a little bit further down the line, right? Now it's usual to have like to see DevOps positions or like anything similar, because there's a lot of other positions that are related. But when this all started, it was more about changing your culture and changing your practices. So it's going to take a while, I think, until we really nailed like when do you need specific people to do this particular job, or when you can just bring some of the already existing practices and maybe use some open source tools and just really make sure that you follow some of the principles of MLOps, I would say.
And let me get to a follow-up question, because it touched about the DevOps part, and you have a question like, can a DevOps move easily to a MLOps role? What you'd recommend to learn, tackle to make that move?
Yeah, I think so. I mean, it's the same as now you have a lot of like programmers moving into machine learning in a way also, because they kind of learn a little bit of data science, a little bit of machine learning, and you can easily like understand the basis and apply a part of it to these machine learning applications. So you don't really need like a PhD to do a very simple, maybe to work on a very simple data science project. Like not everything is like super deep research. So in the same way, I would say it's important to understand like the machine learning side. So understand how these models work, what they are kind of in the background, so to speak. But it doesn't require like a full degree in machine learning. So it's really just a matter of adapting and understanding these new aspects of the models. Or maybe and this is why I'm not going like super deep into a very specific aspect, because maybe in some places it's more about the data engineering part and about the requirements for that particular pipeline. So for those things, for fetching data from the data sources to make sure that the data platform is available, working fine, everybody can access it, and there's other aspects there that are different maybe than a situation where you need to handle just models and it's more about managing all of your models in production. So I would definitely say the thing to like, if you want to like kind of do DevOps sort of in this machine learning scenario, machine learning is the thing to try to understand from a more practical point of view. And there are a lot of resources out there and a lot of courses that are really just focused on the practical parts. So without all of the mathematics and background and all of that, and really just targeting that part.
And having another one, because we're really having a lot of questions regarding the MLOps positions. And then would you think that would be more common in the future? What type of technologies are you recommending?
Okay. If it's going to be common, I mean, I would say so, whether it has this name or a different one. So that's the thing. I don't know if the name is going to stick, but I would say more and more like machine learning is really getting better in a lot of different applications. And so definitely either this position is going to exist or a variation of it, or DevOps are going to understand that they need to also like support this to support kind of the whole process in the company or something like that. But yeah, definitely it's going to exist somehow. About technologies, okay, that one I'm not entirely sure. Well, these pipeline management tools are really important. The model management part is when we're talking about specifically like machine learning applications where you're gonna like your model is going to be a part of your product, right? If you're in that scenario, then anything related to model registry, model management, like you can Google a bunch of different tools and papers. Actually, a colleague of mine just shared a link with me that I can share later, maybe. There was a bunch of resources about applied AI, which is also like a field very much related to this, right? Is how you actually move things from research into production and do all of those things. But yeah, definitely things related to that. So like Airflow, the prefect things that I was mentioning, the DVC tools, like knowing those tools is good. But like I said, these tools are not like super mature. And so I might be telling you, yeah, it's interesting to look into these tools, and then tomorrow there's a completely new set of tools that just came up, because really, like we started, for example, and I've been using Airflow for a while, and during like that time, which is what's like 1 year or two, a lot of the new tools came up. Like every couple of months, we were seeing, oh, now there's Prefect, and Prefect claims it's like super good and much better than this because it has these features. Kubeflow, for example, is also super interesting, especially for people that are already using things in that scope. But it's also very recent, so you can pick one, and then suddenly you see that there's a number of new tools in the next days. So that's like, I know it's a bit vague, but it's really hard to point you to like.
So maybe like check one and start with that, and then go to another one.
Or just like see like people that are comparing several ones. Sometimes that's good because they might bring up like the aspects of one that are better than the other, and that might fit better or worse whatever use case you're working on. Obviously, if you're just kind of trying to explore like what is out there and you don't really have a particular application in mind, then it's better to just like maybe pick one, try to explore how you would develop pipelines for that particular tool, because then in a way, like if you think about the pipelines that you're building, the training pipelines, like when you change from one tool to the other, the process, your mental process of how you're going to build the pipeline shouldn't change much. What changes is maybe how you set up the tool, how you then deploy those pipelines into your tool. And the same goes for model registry, right? So if you have a particular thing in mind and you try one tool, then when you move to another one, you shouldn't have to change much like that logic around that particular process.
And since that we're talking about deployments, do you use Google Cloud, AWS, Microsoft Azure, or on your daily job? What type of lessons learned that we have?
Well, I mean, I don't know how much I can say, but no, but AWS, I definitely have used it. And it has a lot of different things, so you can use it for tons and tons of things. I actually think they now have, this is very recent, but they now have like, they offer the possibility of using Airflow in a managed way. So they are the ones managing this thing, and you just use it. And they have that for other things. They also have SageMaker. At one point, I've used also Azure, both Azure and AWS, to try to run experiments, like to set up machines and run one thing from the one end to the other. Lessons learned. Well, I don't know, actually. Like if I have a particular like specific lesson learned, I mean, when you're using very specific things like about these experiments and the images and whatnot, well, it's really important. Like, even if you're just doing an MVP, like even if you're just trying it out, like for a personal project or whatever, that you really track down what you're doing. Because like, what was the process that you followed to build your image, and actually put it on something like a Docker file or something so that you can replicate it, and you're not just launching machines and then you go through the pain of installing everything. Because these deep learning applications, you have so many dependencies and little things that need to be like set up properly. Of course, now like a lot of these things already offer you like predefined images and whatnot. But in the beginning, when I was starting to use some of these tools, we had to like constantly go through the pain of defining all dependencies and whatnot. So really like defining things properly. This is actually more DevOps, right? So having your images defined, your deployment or launch process defined, and everything is like really good. So you don't have to think anymore about it, and you can just really focus on the code that you're running, like the training that you're running.
Nice, really nice. And let's see. From the models that make it alive to production land, how many have you closed feedback loop to improve over time? Well,
by closed feedback loop, I'm not sure if this means like proper monitoring or more the continuous training part, something like that. Like, as much as you can, you should do this for all models. Like, you don't really, of course, there's that MVP stage where you want to like just deploy something, see if it works, maybe in a very contained way. But first, you should almost 100% of the times know what does your success metric look like when you deploy that model. And if you don't have that, and if you're not tracking that, then that's like a red flag clearly there, because you don't know what you're measuring. So you need that. And that's your first kind of signal to have a feedback loop, right? Because if you monitor that, if you know what your success metric is, then you can clearly see if it drops or if something goes wrong. And that should be like your first kind of signal for this feedback loop. And then obviously, if you're doing an MVP, maybe you don't have like continuous training loop prepared or anything like that. But when you see that it's working, or that you start having like an actual impact with that model, then I would definitely say you should put some sort of like feedback loop in place. Even if it's very simple, even if it's just like, okay, every month, I'm gonna pull the same exact data, train with the same exact thing, and just like check if things are better or not, and have this kind of metric, or have this kind of metric, the one metric that you define as success metric, kind of showing you that you should retrain it. Let's say that's your closed feedback loop. You just have an alert if that metric goes down, and you actually manually retrain that. That can be a start, and it's already a feedback loop. Obviously, it's a painful one, but but it's already a feedback loop. But you should always, when you decide that something is in production, it's working well, and it's going to leave the MVP stage, then this is like an important point, definitely. Right, even if it's a manual feedback.
And regarding model bias, there is a way to prevent model bias in MLOps.
Yeah, so actually I've been looking a lot into it and seeing how other people are doing it and whatnot, and there's different applications have different levels of difficulty with this. And it's one thing if you have a model where, let's say, all of your features are numeric and your output is numeric also. If you have this, then probably you can map out, and let's say your output is not only numeric, but it's some sort of scalar. So if you want to map the distributions of these things, then it should be fairly simple. And there's already tools that do this for you, like monitor the distributions of your inputs and outputs. And this can be an easy signal to see if you're starting to have a distribution shift or something like that. And if your model had a bias before, this can also help you catch that bias, right? Because you might have completely different results for a particular group. Obviously, this once again, and this is something that I repeat a lot, I know, but depending on the application, bias looks completely different in one case and the other. And the one that always comes to mind is if you have some sort of decision process that involves like people, and you have like obviously different races, ethnicities, or just gender, then those groups are very easy to see, okay, we should prevent bias here. But there are other things, and there are other like more difficult cases where bias is not as easily understood. And like I was saying, if you have a model where everything is numerical, inputs, outputs, then checking for bias or even checking for data shifts is easier, I would say. It's not like straightforward 100% of the times, but it's easier. When we're talking, for example, about language, it's a little bit harder to see that you have some problems there, or that you have a bias for some particular set of features. And a lot of the times, because these features are not necessarily well defined, right? So I
think we're getting a little bit of technical issues.
I think I broke a little bit.
Yeah, but you're back.
Yeah, sorry, I'm so sorry. Yeah, I was mentioning that in language, bias can be a bit harder to track because you need a lot of information, right, about who wrote or who is the speaker, and you may not have that information. So how do you detect that for a particular your particular application, you have some bias and you're really good at translating a certain group, but not as good as translating a completely different group? This is not necessarily straightforward to explore. But there is a lot of work, and recently there are even, like in big conferences, you have tracks specifically to study bias and problems in language, and similarly in image conferences, in conferences that are more focused in the image parts, you probably have the same. So it's a big field, and it's understudy in a lot of these things.
I have here more like, but I'm hearing myself on your side.
Sorry.
It's okay.
Can you see if it's better?
Yeah, I would say so. So what's the ideal engineers over scientist ratio in MLOps for you?
I don't think there's one. So like the MLOps thing, there's not a one size fits all. Like there will be companies where maybe you can have a tiny team of data scientists and just a bunch of engineers, because you need really a lot of work on the product side and more focused on that. And other companies where maybe you have so many different projects and so many different applications that you really need more data scientists. Like from my experience so far, I don't know if there's a perfect ratio there. So yeah, and this will be a case-by-case thing, I would say.
Yeah, that's true. Every project and every team is different. You must adapt. So since the data scientists and machine learning engineers roles and MLOps are becoming different almost every day, we can see some differences. Which one would you choose in the far future, and which one do you like more?
Oh, that's a very personal question.
Yeah.
I don't know, actually. I don't know. I like the data science part of things and exploring like the different things you can do with the data and the models and whatnot. Right now, I'm much more focused on the second part. So I'm trying to kind of get into the world of MLOps. I don't know if I know it like as well as I would like to be able to say that I like it more than the other one. Because it's also like there's still not a very good a boundary of where does like DevOps start and MLOps start, and where's the boundary between MLOps and really just the machine learning parts? How much should you kind of be looking into when you're tackling this automation part? But for me, it's still not. I don't feel I have all of the visibility over these two fields to say that I like one over the other. Because in a way, I've always worked in machine learning more on the applied part, right? So with a more stronger engineering side and making sure that things go into production. So that has always been my focus. But MLOps is a completely new thing. And so, yeah, it's hard for me to say. For now, I'm going to stick with the pseudo MLOps thing because we don't have MLOps positions. I'm talking about this, but and I mentioned all of those positions, but that's really just a list of that study that Algorithmia did. And so, yeah, I'm going to stick a little bit more with MLOps, I guess.
Okay, that's nice. So you talked about data, models, monitoring as a big difference comparing to traditional software engineering. What about testing the machine learning software? Do you recommend any tool, any approach?
Okay, yeah, so I would say, yeah, machine learning testing is completely different, right? So if you need to test, well, when you're talking about the software, yeah, but still, it has different requirements, I would say. So it's not as much about the tool that I would choose, I guess, as just you really need to understand what you're trying to test for. And probably you have different test suites, and it's not enough to know that that little function that you did does X or Y, and you really need stronger integration tests to make sure that everything is like working smoothly from one end to the other. Yeah, and maybe you're monitoring, I don't know, different performance aspects that maybe when you're doing traditional machine learning, traditional software, you're not so much focused on, because you know that it's not going to have that impact. Maybe you're testing how does your new piece of code, like to train the model, how efficient it is in like terms of training speed using the GPU and memory that it has there. So these are maybe different aspects. Honestly, I haven't been focusing too much on the training code, so maybe I would say there's probably a lot to explore here.
Yeah.
But I don't think it's about the tool as much.
Okay, and so any or all of these tools will auto-scale infrastructure according to the usage, because we talked about some of them.
I wouldn't say all, but definitely a bunch of these tools is also to allow that you auto-scale like with your infrastructure. So an example is Airflow, right? So Airflow won't auto-scale your infrastructure, but it's designed to be put in infrastructure that auto-scales. So you can use different processes, like either like processes that auto-scale workers, and you have some queues to send the jobs to it, or you can actually integrate it with Kubernetes. And other tools will have the same aspect. So this is not. I'm talking about Airflow because, like I said, I work more closely to that one. But other tools will probably have the same, more or less, like in different degrees, but they will be adapted to these infrastructures that are prepared to scale. So I would say definitely a big number of these tools will have it. Not all of them, definitely.
Sure. And you talked about Kubernetes right now. Someone is asking if should we learn it.
I'm biased because I'm using it, so yes. That would be my very straightforward answer. It's not the only way of doing things, but yes, it's a good way. I like it. So yeah, go and learn it.
Maybe can you share like some feedback that you have from it, some lessons learned at the beginning?
With Kubernetes in particular? Like I want to do another disclaimer. I'm no like expert. There are like out there amazing experts in these particular things. I still struggle with some parts. But yeah, I really like Kubernetes in the sense that it allows you for that scaling ability and managing your resources. And I think that part is super important. So if you're looking into these things, into these concepts, I think one thing that it's important to understand is how you can manage this part. So how you can make sure that you're using the right resource. So not just using Kubernetes because you're using Kubernetes, but what is the benefit that you're extracting from it of like how you're controlling your resources. Yeah, how you're like, how much do you want to scale and how you can control that also. Yeah, it's very hard for me to like give pointers there because there's really so much out there. Like you go to YouTube, you look for a Kubernetes tutorial. That's where I would start, right? So if you don't know anything about it, you just try to start with some like really easy things. So you can use, for example, I think Minikube is a good thing to explore because it allows you locally to kind of play around with all of these things. So maybe that's a good one. Yeah, if you look to some tutorials with Minikube, that can be nice. You can actually deploy like some tools like Airflow or Prefect or whatever in Minikube. There's like guides also for that.
Okay, that's really nice. Let's change a little bit of topic because we have a question regarding statistics. Do you use it in your job?
Statistics is a bit vague. Okay, like strong statistics methods recently, maybe not. But yeah, but we have a lot of like data analysis that we need to do, and so we definitely have to use some statistics. But once again, I'm more like right now more focused on MLOps. So in the part where you're working on the models, then definitely yes, like you have a stronger kind of sense of like statistical methods that you need to use to assess those models, to assess those behaviors, to see if like everything is fine. Yeah, I'm not sure if this is a bit vague, so I'm not sure if I answered with what the person wanted.
Well, we're going to have time for it during the networking, so yeah. Please go further if you want to know a little bit more. I have two more questions. So one is, do you have offline models being deployed on mobile apps at Untitled? How would the pipeline work in this case?
So I'm guessing that by being deployed on mobile apps, the person is more like thinking on the sense that the model is running on the actual device of the person, and the answer for that is no. And that would be much different. So if you want to run that sort of model, and I think there was a case like that was very like hyped of Google having Google Translate the model itself running on the device or something. You really need to focus on different aspects, right? So you're not going to deploy the same model that is running like on a super strong server full of resources to like a device that like has much less resources, and you're just going to kill that person's phone. So that would be definitely the focus. You probably, to do these sorts of things, you really need to work on techniques to reduce your model. And there are a lot of techniques for that. But you can, like, for example, have an initial model that you then like apply a bunch of reduction, let's call it in general, techniques that then kind of make a very tiny model out of it that might have sacrificed some performance for the sake of like this resource usage. So I would say your pipelines would have to have that into account. It would have to have a process to do this transition to a sort of smaller model, and then be able to assess like these trade-offs between performance and resource usage. Because obviously, I mean, yeah, anybody can reduce a model into a very tiny thing, but then it can be crap. So you really don't have benefits of putting it in any application whatsoever. But yeah, your pipeline, I would say, focus on that transition to a smaller model. But we don't have that. We are not deploying our models into people's devices.
Okay, that's good to know. And last question for today. Wouldn't it better to have more multidisciplinary people versus more roles?
Yeah, definitely. I don't think so. As I mentioned before, like the roles that were there, they're extracted from that report from Algorithmia. It's just to show that companies are kind of following this hype and creating like 10 different positions that in some cases they will actually mean the same. So you have companies where ML engineer is doing the same as in another company, the data ops guy is doing, and maybe in another company, even the machine learning scientist is doing. So these things are not like, I'm not in favor of having 40 different roles for the same thing. I think there will be a more emphasis on this notion that you need a proper like infrastructure and setup and proper processes for machine learning. And I think there will be kind of a distinction there or an evolution there on the DevOps / engineering side towards machine learning. This doesn't mean that there will be tons of new positions. And regardless of the application and regardless of the position, it's always good for, obviously it's nice to have specialized people, but it's also good to have a balance and to have people that are more multidisciplinary and that can work in cross-functional contexts and understand like different sides of the problem. So this is not, I'm not advocating at all for having like an MLOps team that is very close. Actually, that's the opposite. This whole notion of MLOps is that you kind of remove these silos and you just have good tools that support the other teams, not just a new team for the sake of having a new team. That's not good. Yeah, you want to have like these people being able to collaborate, and so multidisciplinarity is always definitely important for me.
Well, thank you, Catarina. Once again, thank you. It was a really nice talk, and I think we could be able to have a really nice discussion. So let's maybe continue on the networking.
Yes, I will see you there.
So thank you guys for being here. I want to just say a few things before closing up. Don't forget about our call for proposals. We really want you guys to share your work and share anything that you're passionate about with us. Please write a survey. Please use the survey. We really want to know how we can improve, and your opinion really matters to us. And without further ado, let's go to the networking session. You have here the QR code and the link, but we're also going to post it on the YouTube chat. Please meet us there in a few minutes. We can't really wait for it. And thank you.